All right, welcome back everybody. Today we're going to be practicing lists and working with testing and getting comfortable with the idea of coming up with use cases and edge cases, just like you're doing in the current exercise and like you'll see on the upcoming quiz. Before I talk about some of the quiz logistics, as well as a little bit more of the plan for today, you should know that we are going to be using Zoom today. So if you haven't joined, go ahead and join up to your house Zoom via the link in Sakai's Postum tool. And we'll get started on that here in just a few minutes. Today we're going to be practicing the process of coming up with use cases for code, as well as and function skeletons, as well as implementing and testing our code. And this is the practice that we need to get in the habit of moving through as we're getting comfortable with the current exercise and where we're going for the rest of the semester. A couple of quick announcements before we get into it today. First, the UNC Developer Student Club is a computer science organization that is student run and supported by the department. And if you're interested in learning more about practical applications, some of those tools which are a little bit more industry specific than we might cover in a traditional course, I would encourage you to check this club out. The first technical talks are a workshop, a sequence of workshops on the Google Flutter toolkit. And this is a toolkit for creating user interfaces that comes out of Google. These begin on September 27th. And on the slide deck, which I will get on the website as soon as lecture wraps up, there are some links to RSVP for this workshop, as well as to potentially join the Discord for this group and get on their mailing list. All right. So this is an exciting student-led club that's associated and explores some of Google's technologies specifically. All right. A couple of quick 110 announcements, and then I'll come back to some questions before we get into the actual material. So List Utilities is out. This is the current exercise, and this is really great practice for the upcoming quiz. In fact, I think this is the best practice that you have available for where we're going in this next quiz. By now, hopefully you've completed the count in all functions and tested them, and you've got those under your belt. If you haven't yet done those, know that you should really get started this evening so that you're not at risk of missing this deadline. I think these 7 functions increase in difficulty as you move through them, and the concepts kind of build on one another. This is due Monday at 11:59 p.m. I believe I saw a couple of questions related to this particular exercise. Let me just take those really quickly. Is range something you can use for EX05? Yes, you may use range if you'd like, and you may use for-in loops if you'd like as well. There's another question about, is it discouraged to use while loops? Not necessarily. There are going to be cases, remember, one of the trade-offs of for each loops versus while loops is that you lose a little bit of control in your for each loops, and you're guaranteed to have to iterate over each item in whatever you're for eaching, right? Whereas with while loops, you have more control over the iteration. So there are probably going to be cases where a while loop is actually the better approach to use in implementing these functions. And I think it's really great practice in getting comfortable with these 2 different looping strategies to try and weigh which one serves you better in the particular function that you're writing. All right. Let me just, all right, I think that question, Kaki may have already brought that question off the board for me. Thank you, Kaki. All right, I think those are the X5 questions, so I'll come back to the other questions in just a moment. The quiz is Tuesday, and again, no collaboration. This will be very important. Appreciated everyone coming forward who didn't adhere to this on the previous quiz, so just keep it clean moving forward and we won't have any problems. So a couple of questions related to quizzes. When will you get those back? We are almost done grading these quizzes. We went back and forth between how much to do in auto grading versus how much to do in hand grading, and moving through 500 quizzes through manual grading is pretty labor intensive and time intensive because there are lots of little issues like misnamed functions or syntax errors. This is the first time we've gone through a grading process like this, and we should be faster at this in the future quizzes. We hope to have these back to you by the next quiz. Will this quiz be similar in difficulty? I believe I can't actually read this. Hold on. Similar to the length and style of in the last one. Yeah, it'll be pretty similar. I haven't actually sat down to write the questions quite yet, but you can expect something pretty similar in terms of difficulty and length. Can we please have more time on the quiz? Yes, so this is actually something that we're going to be doing. This will be more of a take-home style, and we've seen this. I actually am appropriating this idea from some other CS courses after I'd talked to some professors about our experience on our quiz. Many others are using a take-home style where you've got effectively from release until midnight to just get it handed in. It won't be any longer, and hopefully this removes some time constraints. So there'll be the final deadline will be 11:59 p.m. Same length and same expectations, no collaboration, but hopefully this relieves some of the time pressure that folks were feeling on the quiz. What are some good strategies for studying for the upcoming quiz? I think the best things that you can do are to engage with what we're about to do today, because today's practice is going to feel very similar to what we're doing on the quiz, as well as just put some time and effort and energy into this current exercise. I think this is really the best practice and preparation there is for the quiz. The quiz will be focused on list algorithms like the ones that we're doing in this particular exercise. If you did bad on quiz 0, it is not game over, right? So if I would encourage you to check out the syllabus. If you take all 4 quizzes and or if you are absent for one of them, your low grade effectively will be replaced by the final, or the final will be treated as if you were absent for one of your quizzes. So the first quiz, don't stress if it didn't go well, but hopefully this next one will go better, and I would encourage preparing by really putting some time and effort into this current exercise. Great question about tuples and ranges. So is there more practice with tuples and ranges available? We're not going to, I think range is something that we'll actually encounter today and we'll make use of today and show some examples of there. And I think as you start writing more for in loops, you'll make use of range more frequently. It's often used in place of while I is less than or equal to some number of iterations, but I'll talk through that today in just a bit. Tuples are pretty nuanced, and because they're so specific to Python, we probably won't spend a whole lot more time with them in this particular course, but they may come up again. They are handy to have around, and there are some really great uses of them, but I wouldn't stress out too much about tuples because they are pretty unique to this language. Most other general purpose languages don't have that exact concept in them. So in terms of practice problems, we might be able to have some out. I do think if you're already through all of the exercise problems, then you're doing great. But those you should treat as practice problems for this particular quiz. We may have some additional list exercises or problems that we can share that wouldn't be handed in for a grade or anything like that. But if you want more practice, I think we do have a few exercises that the TAs have been working on that we can share. Will memory diagrams be on this quiz? I think that's a great question. We're going to do a memory diagram today. I think for this next quiz, my inclination, I don't want to commit to this 100% quite yet, but my inclination is to keep it focused on code. And then in the last 2 quizzes, I could see us trying to do a memory diagram. We just haven't spent enough time in class together working on these. And I would like to be sure that you all have an opportunity to hand in an actual memory diagram and get graded on that before seeing it on a quiz. So I think we're going to keep this next quiz to code, and then in the last 2, we'll probably see some memory diagrams. Yeah, we will have, we can talk through solutions of quiz 0. We can share those. And there will be office hours on Sundays. All right, so I'm going to pause questions here, and then we'll come back to some questions later on. All right. International students will take the quiz at the 12-hour offset, just like we have done in the past. So you'll begin at effectively 5 p.m. or 4:45 p.m. Beijing time and hand in by 11:59 p.m. Beijing time. just like we did before, but with this new take-home style. Let me just look at these last few real quick. Should we try and get to skeleton functions on every function before getting them filled out? Yes, I think that's actually a great strategy. In terms of the quiz, I don't necessarily, I think hopefully without the time constraint, you don't need to feel like you need to go through and just jot down all of the skeletons. But I do think in terms of trying to solve a particular problem, I really do encourage get the skeleton down first, try and get some tests that allow you to know whether or not your function is designed in the way that you expect it to be and can handle the use cases that you're concerned with, as well as give you some confidence when you're working on the implementation that you're actually making progress before going and trying to start it. And another piece of advice that you'll hear me say again later today is don't just like write down a lot of code or type out a lot of code with bunches of syntax errors and things like that. I think be careful to avoid making syntax errors. And if you find that you've made one, figure out how to fix that before you keep writing more code, because you can find yourself in a really challenging place to recover from if you just got like pages of code that that can't run and it's really hard to fix. So as you add new lines of code and add new statements, just be careful to try and make sure that you're not creating more syntax errors than one at a time. Like get your current thought down, be sure you've got a valid program that you can actually run, and then continue from there is encouraged practice. All right. If you're seeing issues with test suites when you're running tests, I'll show you how to run those from the command line. There seems to be some flakiness in the VS Code plugin, but we will show you how to run that from the command line, and that's actually just as good as doing it with the built-in tool. So the built-in tool is nice because it just has something you can click on, but it doesn't actually give you anything extra. And the command line tool actually winds up being much more, you can have more confidence that it's going to work and have your back. All right, I'm going to lock the questions for now. And there's just one more announcement to talk through, which is office hours, expectations, and etiquette. I've had some reports of people being aggressive and kind of mean in office hours. And I want to remind you that every student who's working for this course and working for me is a human too. And our number one priority is to help you learn. And giving you an answer doesn't help you learn, right? Like if it did, I would just give you all the answers and we would be done, right? But that's not going to help make you more competent as a programmer. And so what we're trying to do is help you get to a point of understanding whatever concept it is that's blocking you from being able to do what it is that you're trying to do. And so we're really trying to teach you how to fish. We're not trying to give you the fish. And so please know that like we are working with your best intentions in mind, and be patient with us just as we try and be patient with you. If there's something that you wouldn't say if you were to me, as if we were working together, please do not do or say something to a UTA, right? If I need, I'll give one warning, and I've given a warning already this semester. If the second time around, office hours will be taken away. All right, so 99.9% of you are absolutely wonderful to work with in office hours, but please just be patient. I know it can be frustrating, but know that like you're working with people who are not paid very well, all things said. It could be making much more money privately tutoring, things like that. They're doing this because they love helping at UNC and helping teach their peers at a scale that's not otherwise possible. So please be patient with them. All right, so what we're going to do today is practice the units concepts that we've been working with. So we're going to see lists, we're going to see tests and things like that. We're going to continue work in the ls24 module.py file, as well as ls24 module test file. If you did not complete those on Tuesday, I would encourage you just to set up these files. You might not be able to run tests in the exact same way. Like you'll want to be sure that you go back and work through that lesson and add whatever code you needed. you can do that offline after today's lesson. I would encourage just following along and participating today nonetheless. But if for some reason your tests aren't running or things like that, don't stress out. We're just going to be going through some motions today, and we can help get those running tomorrow if necessary. All right. So with that said, we're going to jump right into the focus of today, which is practicing implementing a function that's very similar to what you might see in the current exercise or on the upcoming quiz. So I'm just going to give you a brief prompt for this function, and then we're going to go to a breakout session where you and some of your housemates can talk about how to start working on this. All right? So we're going to implement a function named fill range. And the idea is that you're given 2 int parameters. This function takes in 2 int parameters, and it's going to return a list of consecutive integers between those 2 integer parameters in increasing order, and it's going to be inclusive of both of those int parameters, right? So I'm not going to be more specific than this. I want part of this exercise is to take this singular sentence and try and understand and reason through what it's asking. So your tasks when you break out into a group are 1, introduce yourselves, check up on each other. How are you doing? It's been a tough semester so far, but we're almost at the halfway point. So we're about to turn a corner and hopefully getting more comfortable with what we're doing. So check in with one another. And then your first task is to try and establish a function skeleton for this particular function, right? And remind each other of what that is and what's required to have a function skeleton. And then in the module test file, add some code comments. And your code comments should just sort of give some example use cases and edge cases, right? And try and reason through and talk through what you might have come up with for these 2 things. There are some questions on Gradescope to respond once you're completed, and I'll use that to get a sense for how many of you have moved through these exercises with your housemates. So with that, I'm going to turn it over to the TAs, and they will send you into breakout rooms, and we'll have about 10 minutes on this. one more minute and then we'll talk through these together. All right, great work with this. It looks like over 60% of you at least got through the use cases here, and you may have still been talking about the edge cases, but we'll come back and talk through those, and I think with more practice, these things become more comfortable. So while folks are joining back up, let me talk through a few more of these questions. The first is, what is the best way to gain confidence when coding? And the good news here is this is a simple answer. The bad news is it's just time on task. So this is just like painting or learning how to draw or play a musical instrument. Time spent performing the task and reflecting on how you're performing the task after you've gone through it, and trying to use a little bit of the meta mind to decide how did I approach a particular problem? Was that the right way? How might I do it differently? And really just investing some time like on the exercises to get practice. Practice winds up being the best way to improve as a programmer. But thinking about how you're practicing and not just doing the same thing over and over again, but trying out new challenges, which is what we try and do in each of our exercises, is a great way to get better. Will tests be graded? So I can't commit to an answer on this quite yet. I do think we will be looking for tests, so we might just be looking for the existence of some use case tests and some edge case tests. I think there will be some expectation that you write those, and that will be hopefully that's one of the things that we'll do that will be in your interest of helping you work towards a solution. So that you don't feel like you're not getting any feedback from the grader, you don't know whether anything's failing or passing. By writing some tests and just testing some of the cases that you must know are going to be expected, it'll help give you confidence while you're taking the quiz. Are lessons graded for accuracy or completion? Yes, is the answer. So what we're looking for is at the end of the semester, effectively, we're going to go through and look at, for people that showed up to every lesson and responded to everything, what was what's a reasonable accuracy level for someone who definitely looked like they were trying? We've said sort of roughly 80% before. It may wind up being 60% accuracy, and maybe 50% accuracy. The point is, if you're just responding with nonsense, and just checking everything and walking away, you might not expect full credit. But if you're putting in an honest effort, you can expect full credit on participation if you're showing up. And yes, we expect that everyone's going to miss probably 1 out of every 6 or 7 lessons. And if that's you, that's totally fine. We will drop a number of low or incomplete lessons and to give some leeway there. So I wouldn't stress too much. If you're showing up to 6 out of 7 lessons and putting in an honest effort, you'll get full participation points. And the next question actually gets right into the heart of this first task, which is, how do we establish a skeleton function for fill range? Well, we're going to need for lists to be a return type in this case, because this fill range is going to be a function that returns a list. So let's actually jump into the code for this and try implementing a skeleton function here. So I'm just going to put this at the top of my file. It doesn't actually matter where in LS24 module you put your skeleton, but we're going to define a skeleton, right? And the file name is the function name is fill range, and the first parameter. We don't know what to name this parameter. We need to think about this a little bit. So we know that we're going to have 2 int parameters. So I'm just going to make a placeholder here, x which is an int, and y is an int, and we're going to need to think about what this function returns as well. So to get to the question that was just asked on Poll Everywhere, can you have a function that returns a list? And yes, in this case, we're needing to write a function fill range, which returns a list of integers, right? And so just like we can return any other type, like an int or a float or a string, we can return a list of integers, and that's what the point of this function is going to be. For a skeleton, we tend to encourage writing in a doc string that tells you a little bit about what's going on here. So this is going to generate a list of consecutive integers between the params. And the prompt said increasing, right? And I'll just write between params. So that's going to go off my screen a little bit, but that's a completed doc comment. And the last part of writing a skeleton is returning something that's meaningful, right? So we can return an empty list here to complete this function. We know it's not correct. This isn't what the point of the function is going to ultimately be, but this satisfies the return type, right? An empty list is a list of integers, right? Now I want to return back to this idea of what did we name our parameters here, and did we choose good names for these parameters? So remember, the parameters of a function, their names only matter inside of the function itself, and maybe as hints to people using it to give a sense of what it is you're expecting there. But the names really are important inside. And we might name these low and high to give them a little bit more meaning inside the function for what we expect here. All right, so maybe the first integer is the lower integer, the second parameter is the higher integer, and we're going to generate a list between those, and it's going to need to be inclusive. Right? So this satisfies what we would expect out of a skeleton function. We've named it, we've defined our parameters, we've defined our return type, we've added a doc string, and we're returning a fake but valid type of value that satisfies the return type. So even though this isn't correct, we can actually call this function and get an empty list back, and that means we can start to test it and play around with it. It also gives us some confidence that we know what the inputs are, and we can start thinking about that. All right, so this is the skeleton, and now I'm going to jump over to what we might think about our tests. So I'm just going to add some comments here and say, okay, for use cases, maybe we have an example function call like fill range, and the low parameter might be 1, the high parameter might be 3, and we expect, and maybe I'll write just a comment here, usage and expected result. Right? So this is just me writing in some comments, just jotting down some expectations of how I think this might work. 1, 2, 3 is what we expect back from this usage of the fill range function. Right, let me make that just a little bit bigger. So this is a function where the prompt said that what we expect back is going to be inclusive, right? And it will increase in value between the two. So that might be one example. You know, we could come up with fill range 100, 101 as another example use case, and this would give us back hopefully a list that includes 100 and 101 in it. All right. So use cases are like ways that you would expect someone to use a function. These might be examples that you would give somebody in order to demonstrate its purpose and its use, and they're sort of good, well-intentioned examples of how this function gets used. Edge cases are, on the other hand, looking for weird ways or unexpected, surprising ways that someone might try and use our function, just so that we think about and are sure that we behave in some predictable way when this happens. So one potential use case might be, well, what happens if we give the numbers in opposite order? Well, this isn't specified in the prompt, and what I can tell you is on the quiz, we would specify what we expect of you in an edge case like this. We wouldn't leave that ambiguous. But if we're thinking about like in the real world, when you're trying to design a function and no one's giving you the specifications, you're coming up with those for yourself, you kind of have to decide, well, how do I want to behave in this? And you could imagine in this case, there's probably two meaningful ways you could respond. You could either return 1, 2, 3, or you could return an empty list. And for our purposes, in today's lesson, we're going to choose the simpler route. Let's just return the empty list. And maybe if there's time, we can make this a more sophisticated implementation. One more example, possible edge case that I can kind of imagine off the top of my head is what happens if you give the same number for low and high. And in this case, we actually do have, because we're talking about the returned list being inclusive of both ends. In this case, I think we would expect there to be the result to be a list that has a single integer in it, which is just that one number. Right? You probably came up with very different use cases and edge cases with the specific arguments and expected result than I did here. But I think these hopefully were in the same spirit of those that you came up with. The idea is we're starting to think about, what are our concerns? And once we have these sort of jotted down, we can turn these into test cases pretty straight away. So what we're going to do in the next breakout is I want you to actually try turning these edge cases and use cases into actual PyTest tests. And you should have some examples in your file down below of how to do that. One of the things, and actually let's do one of these together, because there's one other thing that I meant to mention about testing before that it just sort of slipped my mind. All of the tests that we wrote on Tuesday followed this very similar pattern where all we had was a single line assertion in those test functions. But what I want to give you is another example of a test function. So def, we're going to test here fill range use case 0. All right, that's a very long function name, but that's okay. And our test functions are ones that begin with test underscore, right? And then it needs a unique name. You want the name of the function to be somewhat descriptive. I'm going to skip over adding a doc string here, and I'm going to go ahead and set up some variables. So my first variable is going to be low, and that's going to be an int in 1, and high, and that's going to be an int in 3. And I'm going to say expected result is a list of integers, and that's going to be 1, 2, 3. Right? So what we need to import list in our test file. So from typing import list, right? What I didn't actually mention before is these are true functions, just like we've been writing for the past few weeks, right? So you can have variables in these, you can have loops in these, you can have conditionals. There's nothing that's special about the functions that are test functions other than the way that we name them and that we put them in a module that is made for testing. So we can have an assertion here that is assert fill range low high is equal to expected result, right? And we are seeing that we didn't actually import fill range. So we had imported total and join from our ls24 module. So I also need to import fill range to make that name be bound to the definition in the ls24 module, right? So I needed to import that function, and now we can call that function. In the one little piece of additional nuance that I wanted to tell you about test functions is that you can have variables, and oftentimes you'll see that adding a pattern where you have variable names like these allows you to very quickly, like you can copy this particular test function, rename it, and then change these variable values and have the same type of test in many different places. So what I want you to try doing in this next breakout is, for your other use cases and edge cases, go ahead and try adding some test functions before we go correctly implement our function. Right? So with that, I'm going to turn it over to the TAs and allow you all to work on implementing tests. And I'm actually going to leave up this example so that that's there for reference. 2 more minutes on this, and if you want to go ahead and try rediscovering and running your tests, go for it. Oops. All right, we are going to talk through these and come back to synchronous. So one of the questions that came up on Poll Everywhere, that's a great question, is there an expectation of using variables or just using the direct function calls? No, there's no expectation of needing to use variables in this way. This is demonstrated, and you'll find there are just some places where when you're writing tests, it helps to put names on the things that you're trying to do. But if you don't find that helpful or particularly useful in a given test case, you certainly don't have to do this. All right, so I'm just going to add one more. I'm going to add an edge case here, and I'm going to update this so that my low was 3, my high was 1, and my expected result was just the empty list, right? And so what's happening here is, and I need to rename my test, so do be careful because this will lead to errors. In fact, I might even show you the error that this leads to. It'll look like this, there's only one test when really there should be 2 if you don't actually rename your tests. So I'm going to name this edge case 0. Right? I'm going to leave I'm only going to have 2 test cases for the purposes of time and trying to make progress. But the idea is we add a number of test cases and what we expect back. And then if your tool is running, we should be able to rediscover tests and see that in lessons, here are my 2 tests for fill range, right? And once you rediscover those tests, you might even get a hyperlink above your definition where you can run a particular test by clicking on it, right? And that test is failing, right? So if we look at why is it failing, well, assert empty list is equal to the list with 1, 2, 3. Of course that's failing, right? Now, oddly, our edge case test here is going to succeed, right? Because our current skeleton implementation returns the empty list. So it looks like we've got that working, right? So when you write these test cases, before you even go and implement anything from your skeleton, you probably are going to have a test case that passes. And the key is to be sure that it still passes after you've correctly implemented your function. Right? Now, I told you that I would demonstrate running PyTest from the command line one more time because VS Code's built-in testing tool can sometimes break. And if that's the case for you, what you will see or what you can do to run PyTest on your own is say PyTest, Python -m for module, and we're running the PyTest module. And then you give what we call the path to the file. And this is a little bit different than the Python path we were talking about in the last lecture. So you would say lessons / and then ls24 module test.py, the file name. Right? And when we run that, we would see that 7 tests passed, but one failed. And if I wanted to look at what test was it that failed, it was the fill range use case 0, right? So you can run your tests in that way from the command line, and we'll post those instructions in the resources area of the website here soon as well. All right, so now that we have our test cases and we have a sense of what this function is supposed to do, the last thing on our list of actually making progress here is to go and do it. All right, so before I turn it over to you, let me just look at these questions one more time, and I'll come back to some that aren't particularly. Okay, so a great question here is, can you have multiple asserts in a single test? Yes. We at this stage don't really have a good use case for having multiple asserts, but absolutely, if we wanted to say something like assert the length of fill range of low high is going to be equal to the length of expected result. We could do something like this with 2 assertions. In this case, the first one is actually covering the second one, right? They wouldn't be equal if they had different lengths, but we'll see later as we start learning about other compound data types that you will need multiple assertions in a test in order to know that it's actually behaving as you'd expect. And all assertions in a given test need to pass or evaluate to true in order for success. All right. So I talked about that one. Is it possible that you might get stuck in an infinite loop? Yes. The computer has no way of knowing whether or not you've written an infinite loop when you go to run your program. In some simple cases, there might be ways that we could tell before running your program, but in general, one of the interesting theoretical computer science things that's proven later in computer science courses is that there's no way to determine whether or not your program has an infinite loop in every case. And so it doesn't even try. And so if you do test with an infinite loop, you'll want to be careful. You may just need to restart VS Code and that'll be fine. If you are following along in lecture but not on Zoom, you should be fine. We are taking attendance on Zoom, so do try to get on Zoom the next time around. But for international students, you're able to complete that async. All right. Okay, with this, I'm going to turn it over to you for the last step here, which is to try and actually implement fill range with your neighbors. I would encourage doing this individually first. When you get into breakout rooms, give each other a few minutes to work on fill range. And then after each of you has had a chance, try running your tests, seeing if you're passing. And we'll come through and we'll spend about 10 minutes on this. And hopefully you can at least take a first pass at an implementation of fill range. 2 more minutes. We will resume at 5:50 p.m. One more minute. All right. So hopefully you got a start on this or successfully implemented it. And if you got through it, a nice challenge is making this work regardless of the ordering of your parameters. Right? So I'm going to jump in and let's think about how we might approach this. So one of the first things I would encourage you to do is when you're working on a function like this, where you're building up some result, which most functions tend to do that, I like to go ahead and set up my result as a variable. You might call it the generated list or something else, but result's fine. And this is going to be a list of integers that is initially empty, and I'm going to return that result, right? And so just going ahead and setting up where is it that we're working, what is the list that we're working on, or what is the number we're accumulating into, or later we'll see objects, what is the object we're building up. Just going ahead and setting that up and being sure to return it. And then your problem is narrowed in down to just what do I need to do as part of my algorithm to implement this particular function. So I'm going to use, I'm going to go back to our while loop as practice and say have an integer that's I, and I'm going to start my integer at low, right? So we're trying to loop from low to high and add each of those numbers between to result, right? And so here I might say while I is less than or equal to high, because we're being inclusive, and I need to be sure to increase my I variable by 1, because remember with while loops you're responsible for increasing your counter variable. You have to be the one to do that, right? Now we've got to be careful here because we might wind up in a situation where we reach an infinite loop, in which case we'll want to reason through that before we go run this, but that's getting a little bit ahead of ourselves. And so what we might try and do next is be sure that, okay, we want to add whatever I currently is. We want to append that to the list result. So result.append I, right? And this was a question earlier that I saw in Poll Everywhere, which was, can you use append and pop in code? And yes, you can, and this is how it works. Because lists are mutable, meaning you can change them, right? You don't have to do anything. Append doesn't return to you anything valuable that you need to know, right? So if we look at its signature, we see that it returns none. This is just a procedure that modifies result, right? So result, after calling the append method on it, has now whatever I was at that time added onto it. All right, so let's think through whether or not this might work with our edge case. Right, so our edge case is we gave a big number to low and a little number to high. So I would start out as a big number, like say 10, and high was 0, while 10 less than or equal to 0, that would be false initially, and this should be okay. We shouldn't have an infinite loop in that case, right? So I'm going to save this, and I'm going to go back to my module, and I'm going to try running my test again. And it looks like I passed my first use case, and now I'm going to run my edge case again, and that passed as well, right? If I went back to my complete testing suite, I could run all of the tests in my lesson 24 module through this tool in this way. But a question came up, why would I need to use this particular Python-M PyTest way of doing this rather than the tool? Well, if for some reason your tool isn't working, and we've seen this in a few cases today in office hours where you get an error like undefined configuration file or some things that we haven't been able to get to the bottom of. But in all of those cases, testing your code using the command line, and these are running those same tests, right? These are two different ways of achieving the same thing. Both when I run this particular command, it's running through all of the tests in my test file. Same as when I use that tool. There's no difference between what these two things are doing. Both of them are running the exact same testing suite underneath the hood. All right. So before I get to the last few questions here, I want to talk through one other concept that we've looked at, which is ranges and for in, right? So this was using the while loop, which we had looked at before the last quiz. And let's think about, well, what if we wanted to use a for in? When you go to change some code, one of the things that I would recommend is just commenting it out. And you might find that, wow, it seems like if I had 10 lines of code and I wanted to play with some other different approach, that's pretty difficult to do. That feels like a lot of typing, and you might introduce other errors. So one of the things that is built into VS Code in many programming editors is the ability to block comment out a whole sequence of lines of code. And the way that works is if you select many lines of code and press Control and then /, that / is adding comments to this block of code or removing them from it, right? And so that's a very quick way of blocking off some lines of code. So if we're trying to use for in and range, we might say for I in range of low to high, and result.append I, right? So remember, range gives us back a sequence between low and high, and I'll come back. There's a little bit more to say here. Hopefully you're catching on to something potentially troublesome with this. And then a for in loop is setting up this variable I inside the body of the loop, and that I will be subsequently each value in the sequence that range produces. And so each time this loop runs, we're going to append I, and it feels like this should be pretty close to what we had before in our while loop implementation, right? So I can go back and try running my use case, and let's see what happens. Well, I've got an error now, and I should look at this assertion and try and see what's going on. So if I hover over that error, it says assert 1,2 equal to 1,2,3 is false, right? So it looks like we forgot that range is not inclusive of the upper bound, right? So to use range in this way, we would have needed to add 1 onto the upper bound, right? The definition of this function that we gave as the prompt was it should be inclusive of both the low end and the high end of those two parameters. But the range that's built into Python is exclusive of the high end, right? So I make that change, I save my file, I try running this test again, and I'm back in business, right? So this is just a quick review of that concept. And now I'm going to jump to some questions in Poll Everywhere. So the first question is quiz 1 cumulative. I would say anything that you need to use on exercise 5 is going to be fair game for the quiz. We're not going to specifically emphasize early semester ideas, but programming in general is just a cumulative practice. And it's really hard to write quizzes that don't make use of things that we learned prior to the first quiz. So everything winds up being somewhat cumulative, although the emphasis and the thrust of the quiz is really about what we've been looking at with lists, and we'll feel like use exercise 05 as sort of a basis for understanding and getting a feel for what to expect. For exercise 05, is there an expected number of edge or use cases? The best rules of thumb are on a slide in the previous lecture, and I would encourage 2 use cases, like just what are 2 different ways that you could imagine someone using this function. And then for edge cases, are there unique edge cases that you think are worth covering? And so there's not going to be a specific hard and fast rule here. In general, if you've got lots of if-then statements, you typically want to be able to have one test per branch of an if-else. That's one heuristic you can use. But really you're trying to think through, for all of the different ways this particular function can run that are like distinctly different, like they reach different branches of an if-else, for example. Do I have a test that covers that case and actually uses that code? Or are there some lines of code in my function that no matter which of my test cases so far I've written don't actually ever reach that line of code? And if there's a line of code that you think you've written in some function that no test case reaches, I would encourage you to try and imagine writing a test case that would reach that line of code. So why are edge cases and use cases important? What we're really trying to achieve with this concept is thinking about our function and what it needs to do and how it's supposed to work in obvious cases, and also how it might need to work in some less obvious cases. And this is part of the practice of understanding how to go about implementing a function at all. And so this is the purpose is sort of twofold. One, once you've actually implemented these tests, you can very quickly go back and test your code and be sure that it's actually doing the things that you expect it to do. And 2, in thinking through these different scenarios, it's going to give you a clearer picture of what the expectations of this function are. And so one of the problems that is very common when you go and try and tackle a new function or other type of unit of functionality in a program is you've got a rough sense of how you think some function needs to work. But until you start thinking through very clearly what are some inputs, what are some expected results, and things like that, there's a lot of ambiguity in your head. And so if you just try and jump right into programming some solution, it's often the case that you won't think through many of the different ways that your function might need to work. The next question is, what is the idiom? So in exercise 5, you'll see that after each function that we ask you to implement, there's an example of how you would do this using what we call idiomatic Python. And many of the functions that we ask you to write are reproductions of functionality that's built into the programming language. And the reason for this is it gives you a sense of, in really good practice for applications of some of the concepts that we're learning and practice thinking algorithmically and computationally. Now, in all of the things that you wind up writing are things that are having to happen behind the scenes. But when as we move further into the semester and out into your programming careers, you should know that many of the things that you're implementing for this particular exercise are built into the Python programming language, and you could achieve in a much simpler way by making use of what's built into the function, right? And the idea is we really want to teach you the fundamentals of programming and how to think like a computer scientist. And the best way to do that is similar to how artists learn how to become artists, by reproducing famous works that are considered great. Well, many of these functions that are built into the languages are so fundamental to the types of challenges that you'll see in programming and computer science that there's really strong benefits in reproducing those algorithms, even though you shouldn't have to go write any of these ever again after this course. We're 2 minutes over time, but I'm going to try and move through. I'm going to lock questions here and see if I can't move through these last few real quickly. But if you need to go, I apologize for going over time, but I think getting through these questions is probably going to be valuable. So let me just add them up here on the screen. Do we need to specify if a test is a use case or an edge case in the name? No, you can name your test functions however you'd like. I was being a little bit lazy in my examples here. Naming them something that describes your test is good practice, and that's totally fine. Can you do a for-in loop for a negative to a positive integer? Great question. Yes, but with some nuance here. Your step is going to need to be -1 instead of 1. All right, so let me pull up the REPL here and actually give a demonstration of this. So Python, if we do something like R is a range from 10 to 1, and then remember that third parameter, which is optional, and we need to give it how we move from one direction to the other, from the start to the end. And so now if we see R0, that's 10, R1 is 9, and if we did for x in R, our range, print x, we would see that we're moving backwards like that. So you can move in a backwards direction, but you need to be careful to specify a step that makes sense. Are lists composite data types? Yes, the idea of a composite data type or a compound data type is really just that you have more than a singular value in them. And so with lists, as we're appending more and more values, you would think of those as compound or composite. All right. I don't understand why we're adding values to a list. Shouldn't we just use the range function? I thought the whole point of a range function was just to list I'm going to try and complete the blank here and say list out the values in it. Yes, so this function feels a little bit contrived, and it is, but there is a difference between a list that has a range of values in it and a range, right? So one of those fundamental differences is you can't ever go and change the numbers in that range. Whereas with our list, we could generate this list that's our range of values and then go use it somewhere else and maybe double each of those values or compute the squares of each of those values. The fact that we have a list that includes all of those values is different from the idea of a range. But really, this is another example of the type of function that is mostly about getting practice thinking in this way and taking on, this is a pretty arbitrary problem. But there is a difference between having a list that has all of those numbers in it and an actual range. Can I use the parameter instead of I? Yes. Oh, fantastic question. I love this. So we, in our environment diagrams, know that parameters are local variables inside the frame of a function call. So in this example, I'm actually going to just demonstrate this really quickly. I'm going to comment out what I had before with my for-in, and then I'm not even going to have this I variable, right? So I used I because it was somewhat conventional. But you could have said, because we didn't need to ever use low again, we could have just used that low parameter name and used that as our counting variable and not had the extra variable I. Now, if we, after this loop, needed to know what was low for some reason and we needed to use it somewhere else, this way wouldn't have worked. But absolutely, you within a function call are free to change your parameter values. In the quiz, do you have to specify I int low? Or can you just say I is low? So for local variables, if you are initializing them on the same line, you are free to let that be implicit. However, for function definitions, especially for function definitions, you have to specify your parameter types and your return types explicitly. We'll be looking for that. But for local variables, as long as you're initializing it on the exact same line as you're declaring it or using it for the first time, you can let the type inference be implicit there. That's okay. So those are our questions, and there was one more diagram I just realized, and for the people who have left, I'll just make a post about this. I'm not going to include this question. I'll take it off of the Gradescope assignment since we didn't get to it, and we'll come back, and in the next week we'll spend more time after the quiz looking at environment diagrams. So again, I apologize for going over here. Hopefully getting to the bottom of those questions was valuable. But with that, have a great rest of your evening and good luck on exercise 5.